In this video, we're going to talk about how we can include something called interactions within a linear model. So far, the linear models we've looked at have considered that each explanatory variable affects the response variable separately to any other explanatory variables. But we might have cases where the response depends on a combination of the two explanatory variables. Here's an example of what we mean by this. We can think about how plants grow, which is often in response to sunlight as well as the amount of water. But it doesn't matter how well lit a plant is, right? It might get the perfect amount of sunlight, but if it doesn't get any water, then it's never going to grow at all, right? So there's an interaction between sunlight and water, right? You need a certain amount of each before the other one can have any effect on the amount of plant growth. Now, to include something like this in a linear model in R, we can indicate that explanatory variables contain an interaction. And the way we do this is when we're specifying the model formula, instead of using the addition operator, the plus symbol between explanatory variables, we can use the multiplication symbol, right? The asterisk that you see here, which indicates that these two explanatory variables should be included with a possible interaction between them. This is what we would see when we then look at the coefficients of the model using the tidy function. As we've seen in previous models, we'll get an estimate of the intercept, and we'll get an estimate of the continuous explanatory variable study hours with an estimate of the slope, 1.91. The tutoring variable is categorical, so that's been dummy coded. It has two possible values, yes and no. In this case, no has been reserved as the baseline, and we have an estimate here of how much the response varies if tutoring is yes. Right? We see that we're predicting an increased value of the response that's 5.3 units greater. The final row here represents the interaction between study hours and tutoring when tutoring is equal to yes. And this represents a difference in the slope, right? So remember the baseline slope effectively is 1.91, and here we're saying that tutoring is yes, then actually the slope is this amount different. What does that actually look like? Well, this on the left here, this graph represents the model without an interaction. So if we just said study hours plus tutoring in our model specification, then we would get these parallel slopes, right? Where if tutoring equals yes, then our intercept is about 5 units greater, or a little bit more than 5, and the slopes are equivalent in the two models. On the right, we can see what happens if we include interaction between the two terms, right? Not only are the intercepts different, but the slopes are now different as well, okay? And we can see that this actually seems to fit the data better, right? The points here have been color-coded to represent whether tutoring is yes or no, and we can see that the blue and red lines seem to go better through the center of the points when we allow this interaction.